Here's a horizontal number line, and we're going to place a segment on that horizontal number line that starts at 5 and goes to 11. And you probably already know that to get the length of that segment, you just do 11 take away 5, which is 6, so the length of the segment is 6. Or you could just count it out, starting at 5 and counting 1, 2, 3, 4, 5, 6, and you'll land on 11. That's another way to find the length. To find the midpoint, we find the mean of the two endpoints, or the average if you like. In this case, it's 11 plus 5, which is 16, and 16 divided by 2 is 8. So the midpoint is 8. Here's a vertical number line. We'll place a segment on that. That starts at 6 and goes to 14. 14 take away 6 is 8, so the length is 8. And 14 plus 6 is 20. And 20 divided by 2 is 10. The average of the two endpoints is 10, so the midpoint is 10. Now we'll place the horizontal segment on a coordinate plane, and we'll place our vertical segment on the same coordinate plane so they share endpoints. And what we're going to be concerned with is this new blue segment, which connects the other two endpoints of our horizontal and vertical segments. But we already found the midpoints, 8 and 10. Now, because we're on a grid, we're going to cut our segments in half and slide half of each segment as shown. And you can see it looks like we've got the midpoint of the blue segment, 8 and 10. And the reason we know we have that midpoint is because we have two congruent right triangles. And the reason they're congruent is side angle side, where the right angle is the angle. And that means that the hypotenuse of one of the right triangles has to be congruent to the hypotenuse of the other. And since those two hypotenuse are part of the same segment, we know by definition of a midpoint that 8, 10 must be the midpoint of the blue segment. Well, let's look what we did then with this particular example. The blue segment had endpoints at 11, 14, and 5 and 6. And we found the average of the two x-coordinates, 11 and 5. So 11 plus 5 is 16 divided by 2. And we did the same with the two y-coordinates. 14 plus 6 is 20 divided by 2, giving us that the midpoint was 8, 10. Now let's look how that would play out if we didn't actually know the coordinates. We just had them labeled x sub 1 and y sub 1 as one ordered pair, and x sub 2 and y sub 2 is the other ordered pair. Well, our formula would look like this. We would add the two x-coordinates and divide it by 2, and add the two y-coordinates and divide by 2. And since we don't know what the coordinates are, that's as far as we can go right now. And that's going to be called the midpoint formula. And here it is, also known as Theorem 22. So if you're given two coordinates, x sub 1 and y sub 1, and x sub 2 and y sub 2, to find the midpoint of the segment that has endpoints which have the coordinates of the two pairs given, you simply find the mean of the two x-coordinates and the mean of the two y-coordinates, as shown in this formula. Well, let's do an example. We're going to use the formula that we've written across the top, and we've been given a pair of coordinates, 12, -4 and -3, 6. Well, I like to write as shown, x sub 1, y sub 1, x sub 2, y sub 2, and then I plug them into the formula as shown. So 12 plus -3 over 2 and -4 plus 6 over 2 gives us 9 over 2 and 2 over 2. In lowest terms, we would get 9/2 and 1. We'll write the 9/2 as a decimal, 4.5, 1, the midpoint of the segment with endpoints that have the coordinates given 12, -4, and -3, 6. We'll do one more example. Our endpoints are 0, -7, and -8, -9. We plug in x sub 1, y sub 1, x sub 2, and y sub 2. Plug them into the formula as shown. We end up with -8 over 2 and -16 over 2. Our midpoint then is -4, -8. In this lesson, we looked at Theorem 22, the midpoint formula. Given two pairs of ordered pairs which represent endpoints of a segment, you take the average of the two x-coordinates for the x-coordinate of the midpoint, and then find the average of the two y-coordinates to get the y-coordinate of the midpoint. And that's Theorem 22, the midpoint formula.